Good morning students. Today we are going to see a design thinking based lecture on Lagrangian multipliers. So Lagrangian multipliers, a design thinking approach is our topic today. So let me introduce what do you mean by a Lagrangian multiplier. So in mathematics, a Lagrangian multiplier is a potent tool for optimization problems and is applied especially in the cases of constraints which are named after a Italian-French mathematician Joseph Louis Lagrange. So this method provides a strategy to find maximum or minimum values of a function along one or more constraints. It is used in problems of optimization with constraints in economics, engineering and physics. So Lagrangian multipliers can be used to solve constrained optimization problems in real world scenarios. So one example is minimizing the cost of producing a certain number of items while adhering to a production of limit. For instance, a company might want to minimize the cost of manufacturing TVs at two factories given a total production target. So this we are considering to be the empathy part. So what is our empathy? So a company has two factories A and B producing TVs. The cost of producing X TVs at a factory A is given by 6x square and the cost of producing Y TVs at factory B is given by 12y square. The company needs to produce a total of 90 TVs. Find the number of TVs each factory should produce to minimize the total cost. So we have defined, next step you have to define. The first stage is empathy. So the next stage is define. First one is define the objective function. So the objective here is to minimize the cost which is represented by the function f of x comma y equal to 6x square plus 12y square. Next you have to define the constraint. Constraint means condition. So the constraint here is the production limit, that is x plus y equal to 90. This can be written as g of x comma y which is given by x plus y minus 90 equal to 0. What is our third stage? So our third stage is nothing but ideate. So for ideate, you have to form the Lagrangian equation, and the Lagrangian equation combines the objective function and the constraint by giving a Lagrangian multiplier lambda. So here L of x comma y comma lambda equal to f of x comma y minus lambda times g of x comma y. Our f of x comma y is given by 6x square plus 12y square minus lambda times g of x comma y is given by x plus y minus 90. And the next step you have to find the partial derivatives and set them to 0. So dou L by dou x which is equal to 12x minus lambda equal to 0. Similarly, differentiating L with respect to y, that is dou L by dou y equal to 24y minus lambda equal to 0. And finally, you have to differentiate with respect to lambda, that is dou L by dou lambda equal to minus of x plus y minus 90 equal to 0. So this is our original constraint. So now we are going to solve the system of equations. So from the first two equations we get 12x equal to lambda and 24y equal to lambda. Therefore 12x is equal to 24y, which simplifies to give x equal to 2y. Here you are going to substitute the x equal to 2y in the equation. So 2y plus y equal to 90 or y is given by 30. So substituting the value of y, you get x value equal to x equal to 2 into 30 equal to 60. Finally, the solution for our problem is the company should produce x equal to 60 TVs at factory A and y equal to 30 TVs at factory B to minimize the cost while meeting the production target. Okay. Now what is the theory behind this Lagrangian multiplier? So the theory of Lagrangian multipliers was developed by Joseph Louis Lagrange at the very end of 18th century. His life destroyed the two independent worlds of mathematics and physics, showcasing a profound and seminal work in each. His method was a new systematic procedure in the solution of previously established and HOC method to solve the constraint maximization and minimization problems. The importance of the Lagrangian multiplier is not of mere historical interest. It is what followed the subject that paved the way for so many optimizations used nowadays. So it is a real workhorse of mathematics for analysis and application. Next, let us see the geometrical interpretation of Lagrangian multipliers. So geometrically, this technique of Lagrangian multipliers can be seen as the requirement that the gradient of the objective function should be parallel to the gradient of the constraint function. that is, at an optimum point, the steepest ascent or descent direction of the objective function will point in a direction wherein the constraint does not vary. This guarantees avoidance of violations of the constraints while optimizing an objective function. Next, let us see some basic applications. So, the Lagrangian multipliers have a lot of applications in most disciplines involved. So, while considering about economics, the Lagrangian multipliers are applied to optimize functions to utility or profit with restrictions on the resource available or the expenses to expend. While considering the physics, it serves as a purpose to solve fundamental problems such as the minimization of energy in a system while respecting the conservation laws. And in engineering, the department is used primarily in design optimization, where engineers are supposed to optimize a design performance subject to physical or material constraints. And regularization methods in machine learning are used with Lagrange multipliers to put constraints on model complexity. So, conclusion, Lagrangian multipliers provides a powerful methodology for finding extrema of a function which is subject to constraint, and this approach combining the transformation of a constraint optimization problem to a system of equations which solves easily the optimal solutions which satisfies both the objective function and the given constraint. This method of Lagrangian multiplier is one of the most effective tools which extends standard calculus to solve more complex real-world problems in everything from economics models to engineering designs and physics problems. Hope you understand about the DT video on Lagrangian multipliers. Thank you.